Hi everyone. Today we are starting a new unit. Unit 8 is called Sequences. And for the first lesson, we are going to define and identify arithmetic and geometric sequences. First thing I want you to do is try this Explore. It asks you to describe the pattern in words for each sequence of numbers and write the next 3 terms in each sequence. I want you to pause the video and try numbers 1 through 8, and then we'll go over them after. Okay, so at this point, you should have completed numbers 1 through 8. So let's take a look at these. For number 1, the pattern was to add 3 to the previous number, and the next 3 terms in the sequence would be 3, 6, and 9. For number 2, the pattern was to subtract 30 from the previous number, and the next 3 terms would have been negative 154, negative 184, and negative 214. For number 3, we would add 100 to the previous number, and the next 3 terms would be 509, 609, 709. For number 4, could be a little bit tricky. You could say that we are multiplying the previous number by a half, or you could say that we're dividing by 2. Either way, the next 3 terms would be 5 over 32, 5 over 64, and 5 over 128. For number 5, we're adding 9 to the previous number, and the next 3 terms would be 82, 91, and 100. For number 6, we are multiplying by negative 3. So notice when we multiply by a negative number, something interesting happens. Each term has an opposite sign. So if we start with positive 1, when we multiply it by negative 3, our answer comes out negative. When we multiply negative 3 by negative 3, our answer comes out positive. So when you see the alternating signs in the sequence, you know that you're multiplying by a negative number. So we're multiplying by negative 3, and our next 3 terms would be negative 243, 729, and negative 2,187. Number 7, we're subtracting 3 from the previous term, and our next 3 terms would be 23, 20, and 17. And for number 8, again, we're multiplying by negative 3. We have the alternating signs again. Our next 3 terms would be 972, negative 2,916, and positive 8,748. So what we're going to be talking about today are exactly what you just looked at, sequences. And there are 2 types of sequences. So you saw both types in those examples. The first type is an arithmetic sequence. An arithmetic sequence is one that we are adding or subtracting. So looking up at the Explore, the arithmetic sequences would be 1, 2, 3, 5, and 7. Notice we're either adding or subtracting to get the next term. Okay, and one way that we know that it's an arithmetic sequence is that the difference between one term and the next is a constant. In other words, you're adding the same value each time. This kind of reminds us of a linear function where we have a constant rate of change. Okay, this constant value is called our common difference, and we denote it with the letter D. So for example, to find the common difference, taking a look at this sequence, we take one term and the next term, and we subtract them. Okay, so now we always do the second term minus the first term. So in this case, 4 minus 1 gives us 3. Or we can use any 2 terms, but we always do, for example, the third term minus the second term. So 7 minus 4 equals 3. And that should work every single time. And that means that D is equal to 3. And that's our common difference, so we know it is an arithmetic sequence. The next type of sequence is a geometric sequence. Geometric sequences are all the other sequences that you saw, which are multiplying or dividing. And instead of calling this a common difference, we call this the common ratio. So a common ratio is when you divide the 2 numbers, you get the same number every time. And again, we're multiplying by the same value. The common ratio is denoted by the letter R. So if we look at this sequence 2, 4, 8, 16, hopefully you should be able to tell pretty easily on this one. But again, if we take our second term and divide it by the first term, we get 2. And again, if we try it with another one, 8, our third term divided by our second term, we also get 2. So that means that R, our common ratio, is equal to 2 in this example. Okay? All right, and last, sequence notation. So the notation tends to be the most difficult part when learning about sequences. This right here is said as A sub n. A sub n represents any term in the sequence. N could be any number. So for example, for this sequence right here, the number 2 is the first term in the sequence. And the way that we would write that is A sub 1. Then number 4 is the second term, that's A sub 2. 8 is the third term, that's A sub 3, and so on. Okay, so if I were to say, what is A sub 6? I would say, well, this is the first, 2 is the first, 4 is the second, third, fourth, fifth, sixth. So the sixth term in the sequence is 64. So you're going to have to get used to that. Again, n just represents the term number. Let's take a look at a couple of examples. So for each sequence, I want you to state if it is arithmetic, geometric, or neither. So if it doesn't have a common ratio or a common difference, then you would just say that it is neither geometric or arithmetic. If it's arithmetic, I want you to find the common difference, and if it's geometric, find the common ratio. Let's just do 2 together and you can finish the rest on your own. So for number 1, looking at it, you might be able to tell whether it's geometric or arithmetic. If not, you're going to have to test it out and either subtract the 2 first terms and see if there's a common difference, and then divide the 2 and see if there's a common ratio. So if you wanted to start by saying, let's see if this is arithmetic, we would subtract 3 minus 1 and get 2, and then subtract the third term, which is 6, minus the second term, we get 3. So it does not have a common difference, so it's not arithmetic. But if we divide the second term by the first term, we get 3. And if we divide this third term by the second term, we get 2. So it does not have a common ratio. That means that this is neither arithmetic or geometric. Number 2, you might easily be able to tell that this is going up by 3 every time. And that is our common difference. Again, if we wanted to show our work, we could subtract the second term by the first term, the third term minus the second term, and we have a common difference of 3. So we're going to say that this is arithmetic. And D is equal to 3. Okay? So go ahead and try to complete the rest on your own, and we'll go over them when I come back.